Welcome to the Explainer. Today, we're diving into a highly tactical runbook, the Grafana Loki LogQL cheat sheet. We're talking 12 essential queries that every support engineer literally must know. Why? Because these are going to drastically cut down your mean time to resolution during those really nasty system incidents. You know the feeling, right? You're staring at a wall of scrolling text while the system is basically on fire and speed is absolutely everything. Well, we're going to get you that speed using pre-forged LogQL queries. These aren't just random examples. They are the exact patterns SREs use to just slice through the noise and hit the root cause in minutes.
So I want you to think about this high-stakes question. What is your exact mean time to resolution when a critical alert fires at 3 a.m.? Picture it. You're just waking up. The screen is blindingly bright. PagerDuty's practically screaming at you. Your brain is simply not in a state to write complex syntax from scratch. You just can't afford that hesitation. Having instant, zero-hesitation query execution ready to go, that's the difference between a minor 5-minute blip and a massive customer-impacting outage.
But hey, the good news is you definitely don't need to memorize the entire Grafana Loki documentation. 12, that's the magic number. 12 precise, carefully constructed LogQL queries are truly all you need to navigate virtually any incident. Keep these in your back pocket, and you are effectively armed with a distributed grep that can aggregate and isolate log sources instantly.
Here's how we're going to break it down. First, queries 1 through 4, the basics. Then queries 5 through 8, metric aggregation. Next, queries 9 through 12, parsing and formatting. And we'll wrap up with a live 3 a.m. production alert scenario. Let's jump right in.
All right, level 1, the basics. Let's look at queries 1 through 4.
Okay, so query 1 is all about getting multi-tenant isolation right out of the gate using exact, negative, and regex label matchers. Look at how we use the exact matcher for namespace equals production, a regex matcher to grab any auth-related microservice, and a negative matcher to filter out staging. The logic inside those curly braces is basically an implicit AND operation. Every single condition has to be met, which instantly carves out a highly specific slice of your infrastructure.
Now, the engine behind query 2 is the stream selector. Mastering this syntax is an absolute game changer because narrow streams dictate your query speed. See, Loki organizes logs into streams based on unique label combinations. When you use a really precise stream selector, you're strictly limiting the scan data. The query engine just skips over the vast majority of stored data, grabbing only the relevant compressed chunks. So your query latency is directly tied to the amount of data matched by the labels, not the total massive volume of your logs.
Once you've got your stream, you've got to search the text, right? Enter query 3, a super high-performance text discovery line filter. Check out how sequentially narrowing this is. First, we grab the payment API container. Then we drop in a literal filter to find lines with the word error. But here's the trick. We instantly follow it up to explicitly exclude timeout errors. This sequential funneling is lightning fast because that literal contains filter uses highly optimized string searching algorithms way before any heavy lifting even starts.
So, knowing your operators is key. Query 4 introduces a very specific, very handy modifier, case-insensitive matching. When you're hunting for an error, who knows if the developer capitalized it as error, or whatever. By slapping that modifier onto your regex filter, you force a case-insensitive match. Always keep these operators top of mind. Exact matches, does not contain, and regex. Pro tip, always try to use the simple exact matchers first for performance and keep regex in your back pocket for when you actually need pattern matching.
Moving right along to level 2, metric aggregation, which covers queries 5 through 8.
All right, query 5. Honestly, this is arguably the single most important metric query in your arsenal. We're creating a service-level error counter over a rolling 5-minute window. We just take our stream selector and error filter, wrap it in a count_overtime function for a 5-minute interval, and aggregate it by service. Boom. You now have a total error count per service across your entire production cluster. This exact query is your foundation for building proactive alert thresholds in Grafana. But, you know, raw error counts can be pretty misleading sometimes. Like, what if you just have a massive surge in perfectly normal traffic? That's where query 6 comes in. This is an arithmetic equation that calculates the exact error percentage ratio. We take the rate of error logs, divide it by the total log rate for that application, and multiply by 100 to normalize the data. If the raw error count spikes but this percentage stays flat, you're just handling more load. Chill out. But if this percentage spikes, yeah, you've got a real bottleneck or code regression on your hands.
Now, to get those metrics highly accurate, you need structured data.
Query 7 shows how to filter specifically by HTTP status code using the JSON parser. But notice that brilliant little addition at the end there? We're explicitly filtering out JSON parser errors. That is an absolutely crucial best practice. In the real world, standard output is a messy mix of structured and unstructured garbage. This strategically strips out those malformed JSON parsing errors so your whole query doesn't just fail because it tripped over one badly formatted log line.
Then we have Query 8, which showcases how to extract embedded values to calculate the 99th percentile latency. We parse the JSON, and then we use the unwrap expression. Unwrapping tells Loki, hey, stop looking at this log line as just a string of text. Instead, extract this specific numeric field, latency, and use it as the sample value for our aggregation. This is exactly how you perform deep statistical analysis directly from your logs.
Let's hit level 3, parsing and formatting. This is queries 9 through 12.
Query 9 is just beautifully simple. By dropping in the JSON parser expression right after your stream selector, you automatically extract all structured fields from your application logs, turning them straight into labels you can interact with. If your devs are logging in JSON, this single pipe command unlocks the whole shebang, the ability to filter, calculate, and format based on literally any key value pair buried in that payload.
Just look at the difference here. On one side, we've got a massive, unreadable wall of JSON. On the other, clean, tactical data. We get this using queries 10 and 11, which center around the line_format template. With line_format, we can surgically extract and reformat exactly what we need to see on the screen. Strip away the noise and format the output as simply IP address, status code, and duration. It is a lifesaver for reducing cognitive load when you're furiously scanning thousands of lines during an outage. And that brings us to Query 12. This is your ultimate correlation tool. When you spot an anomaly in a metric or a failing trace in a distributed system, you need the logs for that exact transaction. By piping a specific trace ID directly into your line filter, you instantly correlate logs across your entire system for that specific user journey. It's really the final piece of the observability puzzle.
Okay, the final act, our 3 a.m. production alert.
Let's pick up the pace a bit because it's 3 a.m. A critical production alert just fired. Adrenaline is spiking. We're going to run through a strict 4-minute incident timeline, simulating this live on Grafana Play at play.grafana.org. Minute 1, the pager wakes you up. Minute 2, isolate the failing service. Minute 3, measure the blast radius by counting the errors. Minute 4, extract the failing trace ID to hand to the devs. 4 minutes. Let's do it. Step 1. We immediately drop in Query 1 to define our stream selector, isolate the production namespace, and filter out the staging noise. Boom! We instantly see the payment service is throwing warnings. Step 2, we pivot to Query 5. We wrap that stream in count__time in sum by service. Immediately, we see the error rate for payments spiking from 0 to 500 per second. Blast radius identified. Step 3, we switch back to raw logs, use the JSON parser from Query 9, and apply Query 12 to filter for status codes of 500 or higher. We grab the trace ID right from our clean line format output. Just like that, in exactly 3 queries from our runbook, we found the service, measured the impact, and isolated the failing transaction. Under 4 minutes.
And that, my friends, is the power of the runbook. When you rely on these 12 precise queries, you completely eliminate the guesswork. You transform from blindly scrolling through endless text to executing a structured, surgical investigation. But I want to leave you with a bit of a provocative question. If you can cut your mean time to resolution down to 4 minutes on the log side using this cheat sheet, what other hidden bottlenecks are currently lurking in your broader observability stack? I highly encourage you to take these queries, build them directly into your Grafana dashboards, and find out. Thanks so much for joining me on this explainer.